Hi, welcome back. This is your teacher Fred, and our topic for today is about arithmetic sequences and series. Consider the following sequence: 5, 9, 13, 17, 21, so on and so forth. This sequence is called an arithmetic sequence because of the pattern for the terms. Each term is 4 larger than the previous term. A sequence in which each term after the first is obtained by adding a fixed amount to the previous term is called an arithmetic sequence. The fixed amount is called the common difference and is denoted by the letter D. If 8 sub 1 is the first term, then the second term is 8 sub 1 plus D. The third term is 8 sub 1 plus 2D. The fourth term is 8 sub 1 plus 3D, and so on. The nth term, 8 sub n, of an arithmetic sequence with the first term 8 sub 1 and common difference D is 8 sub n is equal to 8 sub 1 plus the quantity n minus 1 times D. Let us apply what we have learned. Write a formula for the nth term of the arithmetic sequence. 5, 9, 13, 17, 21, so on and so forth. Solution. Each term of the sequence after the first is 4 more than the previous term. Because the common difference is 4 and the first term is 5, the nth term is given by 8 sub n is equal to 5 plus the quantity n minus 1 times 4. We can simplify this expression to get 8 sub n is equal to 4n plus 1. Checking a few terms. 8 sub 1 is equal to 4 times 1 plus 1, which is equal to 5. 8 sub 2 is equal to 4 times 2 plus 1, which is equal to 9. 8 sub 3 is equal to 4 times 3 plus 1, which is equal to 13. Hence the formula of the arithmetic sequence. 5, 9, 13, 17, 21, so on and so forth, is indeed 8 sub n is equal to 4n plus 1. Another example. Write a formula for the nth term of the arithmetic sequence. 4, 1, negative 2, negative 5, negative 8, so on and so forth. Solution. Each term is 3 less than the previous term, so D equals negative 3. Because 8 sub 1 is equal to 4, we can write the nth term as 8 sub n is equal to 4 plus the quantity n plus 1 times negative 3. Or simplifying, we get 8 sub n is equal to negative 3n plus 7. Checking for a few terms, we get 8 sub 1 is equal to negative 3 times 1 plus 7, which is equal to 4. 8 sub 2 is equal to negative 3 times 2 plus 7, which is equal to 1. And 8 sub 3 is equal to negative 3 times 3 plus 7, which is equal to negative 2. Thus the formula for the nth term of the arithmetic sequence. 4, 1, negative 2, negative 5, negative 8, so on and so forth, is 8 sub n is equal to negative 3n plus 7. We can also find some terms of an arithmetic sequence using a given formula for the nth term. Example. Write the first 5 terms of the sequence in which 8 sub n equals 3 plus the quantity n minus 1 times 6. Solution. Let n take the values from 1 through 5 and find 8 sub n. 8 sub 1 equals 3 plus the quantity 1 minus 1 times 6, which is equal to 3. 8 sub 2 equals 3 plus the quantity 2 minus 1 times 6, which is equal to 9. 8 sub 3 equals 3 plus the quantity 3 minus 1 times 6, which is equal to 15. 8 sub 4 equals 3 plus the quantity 4 minus 1 times 6, which is equal to 21. 8 sub 5 equals 3 plus the quantity 5 minus 1 times 6, which is equal to 27. Notice that 8 sub n equals 3 plus the quantity n minus 1 times 6 gives the general term of an arithmetic sequence with first term 3 and common difference 6. Because each term after the first is 6 more than the previous term. The first 5 terms that we found are correct. The formula 8 sub n equals 8 sub 1 plus the quantity n minus 1 times D involves 4 variables: 8 sub 1, 8 sub n, and D. If we know the values of any 3 of these variables, we can find the fourth. For example, find the 12th term of the arithmetic sequence whose first term is 2 and whose fifth term is 14. Solution. Before finding the 12th term, we use the given information to find the missing common difference. Let n be equal to 5, 8 sub 1 be equal to 2, and 8 sub 5 be equal to 14. In the formula 8 sub n equals 8 sub 1 plus the quantity n minus 1 times D to find D. Thus, 14 equals 2 plus the quantity 5 plus 1 times D. 14 equals 2 plus 4D. 12 equals 4D. 3 equals D. Now use 8 sub 1 equals 2, d equals 3, and n equals 12 in 8 sub n equals 8 sub 1 plus the quantity 5 minus 1 times d to find 8 sub 12. Thus, 8 sub 12 equals 2 plus the quantity 12 minus 1 times 3. 8 sub 12 equals 35. The indicated sum of an arithmetic sequence is called an arithmetic series. For example, the series 2 plus 4 plus 6 plus 8 plus 10 up until plus 54 is an arithmetic series because there is a common difference of 2 between the terms. The sum of an arithmetic sequence denoted by s sub n of the first n terms of an arithmetic series with first term 8 sub 1 and nth term 8 sub n is given by s sub n is equal to n over 2 times the quantity 8 sub 1 plus 8 sub n. Let us apply what we learned. Find the sum of the positive integer from 1 to 100 inclusive. Solution. The described series 1 plus 2 plus 3 up until plus 100 has 100 terms. So we can use n equal to 100, 8 sub 1 equal to 1, and 8 sub n equal to 100 in the formula for the sum of an arithmetic series. Thus our working equation is s sub n is equal to n over 2 times the quantity 8 sub 1 plus 8 sub n. Substituting the values we get s sub 100 is equal to 100 over 2 times the quantity 1 plus 100, which is equal to 50 times 101 or 5050. Another example. Find the sum of the series 12 plus 16 plus 20 up until plus 84. Solution. This series is an arithmetic series with 8 sub n equal to 84, 8 sub 1 equal to 12, and d equal to 4. To get the number of terms n, we use 8 sub n equal to 8 sub 1 plus the quantity n minus 1 times d. Thus we get 84 is equal to 12 plus the quantity n minus 1 times 4. Simplifying we get 84 is equal to 8 plus 4n. Adding negative 8 both sides we get 76 is equal to 4n. Dividing both sides with 4 we get 19 is equal to n. Now find the sum of these 19 terms we get s sub 19 is equal to 19 over 2 times the quantity 12 plus 84, which is equal to 912.